Hello everyone. I would like to welcome all of you to the Geometric Technologies presentation using tomorrow's technology to manufacture today's parts. My name is Mike Sowers and I'm the Director of Pre-Sales here at Geometric Technologies. Before I show you a demonstration of CAMWorks, it's important to understand who we are and what we do. Geometric as a whole is a leading provider of global engineering services and information technology solutions to manage product development as well as manufacturing and supply chain integration across a global enterprise. We're broken up into three distinctive units, business units. Number one being software solutions, which is the product lifecycle management solutions, manufacturing IT solutions, and software product engineering. And then we have our engineering solutions, which is product engineering, manufacturing engineering, and engineering productive solutions. The technology solutions, which I am a part of, is desktop products and technologies for engineering productivity, interoperability solutions as well. So today I'm going to be discussing the Geometric Technologies side of the Geometric family. If you look at our revenue, our consolidated revenue was a little over 100 million US dollars for the fiscal year of 2010. Our current manpower as of September 30th stands at 3,245 employees. Here's a brief overview of the Geometric Products and Technology Solution, which is the Geometric Technologies division. We offer feature recognition, and this is a tool designed to automate the extraction of featured intelligence from models. Our NestLib, this is a fast and flexible and easy to use integrated true-shape nesting library. It's designed to maximize raw material utilization. We also have the eDrawings Publisher, and I will be presenting that for you as well. Dfm Pro, this is an automated intuitive tool for designers to accurately predict the manufacturability of models. But today I'm going to show you how Dfm Pro can be utilized with CAMWorks on the manufacturing side. Geom Caliper, this is an integrated, automated, and easy to use thickness checker for models. And then lastly is the CAMWorks product, which we'll be primarily focusing on in the demonstration today. CAMWorks is a SolidWorks certified gold CAM product. It's an automated and intuitive CAM solution designed to maximize machining productivity. And that's what it's all about, maximizing the machining productivity, getting the part out to market faster, quicker, better, cheaper. So let's go ahead and start up the live demonstration. Okay, so here we are. We've got a part sitting inside of SolidWorks. You'll notice this particular part started out being imported, and then there was services added and SolidWorks features. Now it doesn't have to be designed inside of SolidWorks. It can simply be imported, and then CAMWorks can take over and machine that part complete as well. We also offer a product called CAMWorks Solids, which is the OEM version of SolidWorks. So what I'm going to demonstrate for you today is not only CAMWorks, but the power of SolidWorks, the power of Dfm Pro, the power of eDrawings, and how they all complement each other in today's manufacturing environment, utilizing the technologies that we've developed. So if you take a look at this particular part, I'll kind of rotate it around here for you. And just so you know, during this entire demonstration, and that's inside of eDrawings, inside of the machine simulator, I am going to be using 3D Connection, which is the 3D Connection Space Pilot Pro. So, as I rotate this part around, how long would it take you to program this particular part in a traditional CAM system? 2 days, maybe? 1 day? 4 hours? All right, for you people that really know your CAM systems, let's say it took you an hour. Well, I'm about to program this part from start to finish in about 15-20 minutes complete. And that also includes design changes, which often occur in the programming stages. So to explain CAMWorks, we have two tabs. We have a feature tree and we have an operation tree. The feature tree is basically machinable features. These are not CAD features, but machinable features, multi-axis features, two-axis features, which can include pockets, bosses, holes, slots, T-slots, etc. When you talk about turning, there could be an OD, an ID, a groove, a thread. Wire EDM, you have dies, and you have punches, etc. So the first thing as a programmer, I'm going to kind of analyze this part, and I'm going to look at if I have any challenging areas or difficult areas to manufacture or to program in that matter. Well, I've got a tool that's going to make that a lot easier. It's going to make that part of my job a lot easier, and that's called Design for Manufacturing, which is right here, Dfm Pro. I'm going to go ahead and start Design for Manufacturing, and you'll see that we have settings for rule files, and then what is our type? Turn, sheet metal, injection molding. Well, in this case, it's a prismatic mill. So I'm going to go ahead and run the analysis on it. And what this tool is doing is automatically finding areas that are difficult to machine, or in some cases impossible to machine. And as parts have a lot more features on them, they get more complex, it becomes more difficult to isolate those cases of areas that are going to increase my machining time, my programming time, and ultimately my cost and processing time throughout the whole cycle. Okay, so as you can see, the analysis has completed, and I've got 5 out of 49 rules that have failed. Let's take a look at a couple of those. Well, we've got a linear and angular tolerancing rule that failed, an instance 1. If I right click on that and I select zoom to region, there it is right there. The spacing between these holes is held at plus or minus 5/10. So right away, I'm gonna realize that, hey, I have to run this on a machine that needs to be able to hold these types of tolerances. So maybe my labor rates on my older machine that I've already paid off, I'm not going to be able to manufacture this part. I'm going to have to actually move it to my newer machine that I'm still making payments on, and my labor rates are a lot higher. So I may want to take that into consideration if I'm in the process of quoting this part. Standard hole sizes, flat bottom holes. As you know, flat bottom holes, they're a lot more time consuming to manufacture than a through hole or a drilled hole. We've got something here that really concerns me. Sharp internal corners. I've gotten 2 out of 12 that have failed. So let's take a look at those. I'm going to right click and I'm going to zoom to the region. Kind of zoom out a little bit here. Oh, look at this. I've got a cutout. Well, it's obvious that I'm not going to be able to machine this in any type of a machining center or a milling center. I've got another one here. Shows me as an instance 2. I'm going to zoom to that region. We'll kind of zoom out here. It's identical. So if I fit the screen here, I can see I've got 2 of these guys. Now I'm not sure that this was on purpose, this particular design. I do a lot of families of these parts, and I've never seen this before. So this very well may be a design error. What I'm going to do is send this off to my customer using e-drawings to demonstrate where the area of concern is, and if this is in fact the way it needs to be manufactured, or if it's a design error. And that's real easy to do. I'll simply go to the file, publish e-drawing file, and there's my e-drawing part. Again, I'm using the Space Pilot Pro for all model rotation and display and navigation. Now, what I want to do is I want to put some markups in here for my customer. And that's as simple as going to the markup. I'm going to add a leader line, a text with a leader. I'll just anchor it there, and I'll say this has sharp corners. Is this by design? I can also add the same down here as well, or edit that times 2. So at this point, I can password it, I can send it off, I can go ahead and send that over to my customer by a simple email program. I can save this as a zip file, as an HTML, a web-based file, or even pictures if I'd like. Now let's say that I've sent that off to them. And let's get back into the programming, because that's not going to hold us up, especially with CAMWorks. Okay? So the first thing I want to do is I want to look at the stock. What type of stock am I going to be using? Well, in this case, I'm going to be using an as-casted part. And you can see I've already got it picked here, the stock STL. As you can see, we use bounding boxes, we can use SOLIDWORKS sketches, and obviously an STL file. Now in assembly documents, we can also use another SOLIDWORKS part, which would become available right here if we were in the assembly document. I'll click OK. Let's take a look at our machine. This specific machine is a 5-axis machine because I need that for the fins, the tool crib, the post processor. In this case, I'm just using the 5-axis tutorial post processor. I'll go ahead and select OK. We'll go right over to the CAMWorks 2011 Command Manager, and the first thing that I'm going to do is extract machinable features. Now this is similar to the design for manufacturing, where it's using the automatic feature recognition module, and it's analyzing the solid body of this part. And it's going to find machinable features for us. So we're not going around and we're not telling it, hey, I need you to machine this guy, and I need you to machine this guy, or picking boundaries and so forth. It's done it for me automatically. You'll see that it's found a counterbore hole group. You can clearly tell that they are counterbore holes. They're all of the same dimensions, so it automatically grouped it in there for me. We've got an open pocket here. Well, I'm not going to use this open pocket. So all I need to do, slow click, which is a rename, standard Windows function. I'm going to go ahead and delete that guy. However, take note that it does put it in the recycle bin. So if I do need it, it's as simple as right-clicking and restoring it if required. All right, so let's continue on. Also the hole groups here. We've got another open pocket here. Now these particular slots that you see here, they've got chamfers on them. So what I'm going to do is I'm going to go into the parameters, and the strategy on this guy is going to be chamfer, because as you can clearly see, there's chamfers around this. And I'll do the same for the other one as well. And I'll select OK. We'll fit to screen. Now I'm going to switch over to the operation side, and I'm going to generate operations. This is one of the technological advances that CAMWorks has to offer you today. This is actually pulling from a knowledge-based machining technology database the operations that are required to machine these features. What do I mean by that? Well, for example, those counterbore holes, obviously you're going to need to center drill them, and then drill, and then possibly use a circular interpolation of contour end mill, and etc. So let's generate toolpath on all this. Okay, so I'm going to go ahead and start the simulation. We'll move the simulation bar out of the way here. Now what I'm doing is I'm going to let the simulation go until it's completely machined the part. And the reason why I'm doing this is I want to use a compare feature, which analyzes the simulated machine part against the target part, or in this case the design part in SolidWorks. Once it's finished, I'll select Show Differences, and you'll notice that green is good, blue means we still have material, and red would be bad. At this point we don't have any red, but we do have some blue. These blades here, which need to be done on a 5-axis, and we're going to do that here shortly. And then obviously these little guys right here, which we knew that was going to happen because Design for Manufacturing already told us that. All right, in the meantime, let's see if I've gotten a response back from my customer on these features here. Because this is a demonstration, what I'm really doing is emulating or simulating a customer's response. So at this point, I've opened up the eDrawings file. I can see that there has been a comment, and he said this was an error. Please remove the features. All right, fine. However, you may have noticed that we've already began, or we're almost complete, of programming this part. That's not a big deal. I can simply go over to the SolidWorks side. Let's find out where this guy is. If I can select a face there. There we go. Extrude 13. Let's just suppress these. So I've suppressed them. I'm going to go right back over to the CAMWorks side, and you'll notice what happens. That we've got a rebuild warning. So I'm going to go ahead and process and prompt for a rebuild. Once the rebuild has been completed, okay, so let's go back into simulation. Let's kind of focus on the area of concern here. And once again, we'll let it run all the way through the simulation. I could, if I wanted to, launch into a turbo mode, if you will, which will dramatically increase the speed of the simulation. However, I like seeing the animation. It really doesn't take that much longer. And I'll do the little quick show difference analysis. And you can see that that area has been removed. All right, well, what else? Well, I can clearly see that we've got that blue on the fins there, which requires 5-axis. Still not a problem. So what I'm going to do is I'm going to insert a multi-surface feature, and then I'm going to apply 5-axis machining strategies to it. And that's real easy to do. I'm going to insert a multi-surface feature, and in this case, I can just pick the bottom here. Whoop, something I didn't do there. That's all right. Is the strategy. And notice how easy it is to go right back into it. So there's my multi-surface feature, which is set to 5-axis. I'm going to go ahead, generate an operation plan. You'll see that now I have a 5-axis operation. So what I want to do here is I want to do a pattern, and I want to do an offset from curve. I'll simply select the curve button. I'll zoom up, and all I need to really deal with is just one of these guys, because I'm going to use a pattern feature once I've completely machined this guy. So I'm just walking around here picking the edges. Now you can use the SolidWorks filters to pick edges only if you wish. Okay, so we're good there. I'm going to say I want one cut, and I'm going to do a collision detection. I'm going to apply that against, let's do the shank, non-cutting, and the flute. And I'm going to tilt tool away, and let's give it 25 degrees. And we can verify this in the actual true machine simulator with the kinematics. I don't want to check against the feature surface, but other surfaces. And what are those other surfaces? Well, let's go ahead and just create them. Boom, 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 boom. Whoop, missed one there. Okay, there's a little tiny one in there, I can see it. So I zoom up to it. There you are. We'll go back to a fit. Okay, so we've inserted that guy. And and I want to avoid that. I select OK. Let's go back to an isometric view and fit. Again, let's take a quick look. Number of cuts 1. And we'll go ahead and do a preview, and you can clearly see the toolpath there. Go back to fit. Looks pretty good. Let's launch right into simulation for this particular operation. We'll just watch it walk around there, do a little rotation. Looks pretty darn good. All right. So lastly, I'm going to put a pattern into that. I'm going to go back to the feature. I'm going to right click on that particular feature, and I'm going to say pattern. Insert a pattern, and this is going to be a circular pattern. And what's my axis of revolve? Well, it's going to be this guy, 360 degrees, spaced evenly. And I know that there's 10 of these fins on here, so I'm just going to select 10. And we're done. Let's go back over, take a look at that multi-axis. Go back to a fit, process manager. We don't need, I'm going to close that. Looks pretty good. What I do want to do is I want to change my setup, and I want to put it on the bottom center. So by selecting bottom center, there's my setup. I'll click OK. It does want to regenerate the toolpaths, which is fine. We've done that. Okay, so let's see the machine simulator. I'm going to right click. I'm going to go to machine simulation. And you'll see that because my post was the 5-axis Hermile, or my machine type, sorry about that, that in the machine simulator, that 5-axis Hermile is going to show up automatically for me. I'm going to open up the doors here. We'll remove the toolpath, just so that you can get a feel of how the machine simulation is. Let's slow it down. There's all kinds of controls and tools in here for you. Okay. Now, at this stage, we're ready for post-processing, aren't we? So let's go ahead and save this guy out, and let's go ahead and post-process this guy out. And there you go. That's all there is to it. However, you will notice that my tools are somewhat in disarray or out of order. I've got tool 28, then going tool 48, and so on. Well, there's a real simple remedy, if you want to call it that, and that is Reorder Tools. And I'll simply use the defaults, click OK. Now you can see that we're going to tool 1, tool 2, tool 3, etc. Now, lastly, how about setup sheets? Well, let's go into the setup sheet. We're going to generate. I'm going to leave everything default. Select OK. And then what's going to happen, this is just a standard setup sheet based in XML code, which is displayed as a web page, if you will. And you can see it here, included with graphics. And again, this is fully customizable. But this part is completely machined at this point with the G&M code. If you have any questions or comments, we're going to go ahead and open up the webcast to questions or comments. Please type them in the section that says questions and comments, I believe. Once again, thank you guys very much for your time.